FV is an Excel financial function that returns the future value of an investment based on a fixed interest rate. FV is used to determine how much the investment will be worth at the end of the given period if there are regular and constant deposits at fixed interest rates. An annuity is a series of equal cash flows spaced equally in time. Here is syntax. Rate, the interest rate per period. N per, the total number of payment periods in an annuity. PMT, the constant amount paid each period. If PMT is for cash out, payment value must be negative. For cash received, payment value must be positive, which is like income or dividends. If omitted, it is assumed to be zero and the PV argument must be included. PV, the present value of the investment or the lump sum amount that a series of future payments is worth right now. If PV is omitted, it is assumed to be zero and you must include the PMT argument. Type, the number 0 or 1 and indicates when payments are due. 0 or omitted, regular annuity where payments are made at the end of a period. 1, annuity due where payments are made at the beginning of a period. Make sure that you are consistent about the units you use for specifying rate and N per. The rate argument can be expressed as a percentage or decimal number, for example 9% or 0.09. In this example, a payment of 12,000 is made each year for 10 years with an interest rate of 9%. PMT is a negative number since this money is paid out. Use this formula to calculate the future value. Type is omitted, so it is regular annuity where all payments are made at the end of the year. You can also use type equal to 0 for regular annuity. If the payment is represented by a positive number, put the minus sign before the PMT argument. An annuity due is a repeating payment made at the beginning of each period instead of at the end of the period. In this case, to calculate future value with the FV function, use this formula. Set the type argument to 1. You can omit the PV argument or pass 0. When investing money, the payments are mostly made weekly, monthly, quarterly, or semi-annually. Investment term is defined in years and rate is annual interest rate. In these situations, it is very important that the rate and N per units must be consistent. To convert an annual interest rate to a periodic rate, divide the annual rate by the number of periods per year. For example, for monthly payments, periods per year is 12. So rate equal to annual interest rate by 12. To get the total number of periods, multiply the term in years by the number of periods per year. For quarterly payments, periods per year is 4. So number of periods is equal to number of years multiplied by 4. For a monthly investment of 1,000 for 10 years with an annual interest rate of 9%, use this formula to calculate future value. Use absolute reference for annual interest rate and number of years so that the formula can be copied down. Periods per year is 12. Rate is calculated by dividing annual interest rate by 12. N per is calculated by multiplying number of years by 12. The same formula calculates the future value for quarterly and other periods. Copy the formula down. Future value is calculated for other periods. If the money is invested one time, the future value formula is based on the present value PV rather than periodic payment PMT. For example, the investment amount PV is 12,000. The interest we get from this is 9% annually, which is compounded yearly and with no additional payments. Use this formula. PV is a negative number, PMT argument is omitted. If the compounding periods for the investment are not annual, convert the rate and NPER accordingly. For example, compare the future value for various compounding periods. Enter this formula. Log the cell references for rate, number of years, and investment using $ so that the formula can be copied down. Rate is calculated by dividing annual interest rate by the number of periods per year. Total number of payments is calculated by multiplying number of years by number of periods per year. Enter 0 for NPER. Copy the formula down. Future value is calculated for different compounding periods. Let's look at another example. 10,000 is invested at annual interest rate of 10%, compounded monthly for 5 years. Additional amount of 500 is invested every month. Use this formula. As the amount is compounded monthly, convert annual interest rate to monthly interest rate. Divide annual interest rate by periods per year. Total number of monthly periods is calculated by multiplying number of years by periods per year. Periodic payments made each period PMT and present value PV are included in the formula. To download practice Excel file, please click on the link in the description. If you like this video, please subscribe to our channel.